Let's take a look at some circuits and create some truth tables from them. Hence the title, Circuits to Truth Tables. All right, so this first example, this is something that you should be quite familiar with. This is a circuit that I created using AND gates, OR gates, and inverter gates, also known as NOT gates. Sometimes this is referred to as an AND or inverter or AOI circuit. And I'm going to make a truth table from that. And we'll just take one little piece at a time. Here, coming into my AND gate, I have an X, Y, and a NOT Z. I'll write it up here. X, Y, NOT Z. I can see that's getting ORed or plussed with some other stuff down here. And in this AND gate, I have not X, not Y. Let me fill that in. Not X, not Y. And that is getting ORed with this bottom guy, which looks like Z. Everybody's getting ORed together. So I have created, as you know, this is called a sum of product expression, right? It's a bunch of products. Well, I guess Z is not being multiplied by anybody, but it's a bunch of products being summed up, hence the sum of product. Truth tables are very easy to fill in from sum of product expressions. I just look at one term at a time. These are sometimes referred to as min terms, and I just fill in whatever row whatever row corresponds to each term. So I have X, Y, not Z. I'm looking for X and Y are ones and not Z. That's this row right here. The second, I'm looking for every place I have a not X, not Y. In other words, X and Y are both zeros, not X, not Y, not X, not Y. That's these two rows. And then finally, I'm looking for every place that I have a Z, or every place Z is 1. Z is 1 here. Well, I already did that one. Z is 1 here. And Z and Z. So every place Z is a 1. There, there, and there. Everybody left, I'll fill in with a 0. And that is my truth table from an SOP or sum of product expression. Very easy to do. All right, now we're going to try one a little bit more challenging. This is not an AOI circuit. It's not AND, ORs, and inverters. I mean, I have a NAND here, so it's going to be a little bit trickier. I'm not going to end up with a sum of product expression. So I'm going to do this by creating a column for each logic gate, or at each point, sometimes these are referred to as test points, I'm going to write a piece of the equation. So this first test point is coming out of this first OR gate. I have Y or Z. I'm going to make a column for that, Y or Z. And I'll fill that in a minute, but let's just finish the rest of the circuit. This particular logic gate, this is a NOR gate. So I have an X or Y coming in, but that little bubble there, that means it's knotted. And that is going to get ANDed with Z. So coming out of here, I have X or Y knotted, right? That's this input right here. And then I have a Z. So that is getting ANDed with a Z. And then finally, this last AND gate is going to AND together these two. So for each logic gate, I've created, again, sometimes it's referred to as test points, a little point where I've written the equation. And finally, this last point, I'm just ANDing together Y or Z with X or Y knotted with Z, right? It's just this guy ANDed with this guy, right? I mean, they're both going into an AND gate. So that's my output. Oh, I forgot to fill in my columns. All right, let's do a column for this. Actually, I'm going to do this in 2 steps. I'm going to do X or Y in one column, and then in the next column, I'm going to do X or Y knotted. Now, the reason I'm doing this is because X or Y knotted is just kind of difficult to do in your head in one step. So I'm kind of breaking it up into 2 pieces. All right, anyway, let's do the next column. So that is X or Y knotted, ANDed with a Z. And then finally, the last big column, Y or Z, ANDed with X or Y with a big knot over it and a Z. All right, so one column at a time. This first column, I'm doing Y or Z. So every place I have a Y as a 1 or Z as a 1, I'll fill in a 1. Is Y or Z a 1? No, so I'll fill in a 0. Okay, Z is a 1, so I will fill in a 1. Y or Z is a 1. Again, I'm just looking for every place Y or Z is a 1. And there you go. That's it. Shouldn't be too bad. Let's do the next column. So I'll do this column right here. I'm looking for every place that X or Y is a 1. Every place that X is a 1. I'm just going to do this one piece at a time maybe. Every place X is a 1. That's 4 places. Every place X is a 1. Or every place that Y is a 1. So where is Y 1? That's right there, right there. And then of course these two, but I already did those. That's it. Everybody else is a 0. Now this next column is not, right? I have a not over Y or Z. So it's basically just this guy inverted, not this. So zeros become ones, and of course ones become zeros. All the rest of these guys are going to be zeros. 0, 0, 0, excuse me, 0. All right, now I'm up to this column, which is just the previous column ANDed with a Z. So I'm looking at the previous column and Z. All right, every place I'm ANDing them. So every place they're both ones, I get a 1. Are they both ones? Nope. Are they both ones? Yep, I'll fill in a 1. Are they both ones? Actually, the rest of these are going to be very easy because these are all zeros. So I know that the rest of these are going to be zeros. And I think I forgot to fill in the top guy. That must also be a 0, right? Hopefully you see how I'm kind of breaking this up into pieces. Ooh, and now I just have one more column. I have this guy, which of course is this column right here, and this guy, which is the column way over in the beginning right here. So I'm just looking at those two columns, and every place they're both ones, I get a 1. Let's see, they're both ones right here. That's a 1. And where else are they both ones? That is it. That's the only place they're both ones. Everybody else is a 0, and that is my final column of the truth table. So this last column represents the output F. That's F right there. Now you can see it would have been pretty rough to do this entire equation with just one column, so I broke it down again using a test point for each logic gate, and sometimes even 2 columns for a logic gate. Like NANDs and NORs, I like to use 2 columns. And then you put them together and do your final column. All right, give it a try.